Okay, welcome to a video on the mean value theorem. The goal of this video is to apply the mean value theorem and also to solve an application problem using the mean value theorem. And this is what the mean value theorem states. If the function f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there exists a number c in that interval such that f prime of c is equal to f of b minus f of a all divided by b minus a. Let's take a look at this sketch to help explain exactly what's going on here. This point right here would be a, f of a, and this point right here would be b, f of b. So this side of the equation, so this quotient right here is just the slope of the secant line as we see in orange. This is y2 minus y1 divided by x2 minus x1. And the left side, f prime of c, would be the slope of the tangent line at x equals c. So what this is saying is the slope of the secant line is equal to the slope of the tangent line at x equals c. So again, in orange we have the secant line, and what we're saying here is at x equals c, this tangent line has the same slope as the secant line. It also looks like there'd be another value of c somewhere over here where the slope of this tangent line would also be equal to the slope of that secant line. So all three of these would have the same slope. So in summary, the mean value theorem states that there must be some c where the slope of the tangent line is equal to the slope of this secant line through those endpoints. Let's go ahead and try an example. We want to apply the mean value theorem to this function on the interval from 0 to 1. For the first step, we'll determine the slope of the secant line through these endpoints. So we need to determine f of 1 minus f of 0 all divided by b minus a, or 1 minus 0. Well, 1 to the 2/3 is going to be 1 minus 0 all divided by 1. That's 1. So now we need to find the x value where the slope of the tangent line would also be 1. So we'll find the derivative of the function, set it equal to 1, and solve for x. So applying the power rule, we'd have 2/3 x to the 2/3 minus 1, that'd be negative 1/3. We want to know when this is equal to positive 1. So let's go ahead and solve this equation. Multiply both sides by 3/2. Let's go ahead and write this up here. We have x to the negative 1/3 power must equal 3/2. Now we want x to the first, so we'll raise this to the reciprocal power, or the negative third power. This would be x to the first. Now 3/2 to the negative third power is the same as, would be 3 to the negative third over 2 to the negative third, which is equal to 2 to the positive third power over 3 to the positive third power. So x is equal to 8/27, which is in this interval. So that's our value of c we're looking for. So now we can see pretty well graphically that the slope of this line would equal 1. And you can also see that when x is approximately 8/27, this tangent line would have the same slope as that secant line. Let's try another one. Again, the first step is to determine the slope of the secant line through these endpoints. So we need to find f of 2 minus f of negative 1/2 divided by 2 minus negative 1/2. Okay, so for this one it might be helpful to use the graphing calculator. Let's go ahead and type our function into y1 of x divided by x plus 1. Don't forget the parentheses. Now we'll go to the table. We want to know f of 2, 0.6, repeating, that's 2/3. Let's go ahead and find f of negative 1/2 as well. So our numerator is going to be 2/3 minus negative 1. In the denominator we have 2 minus negative 1/2, or 2 plus 1/2, that'd be 5/2. So now we have 2/3 plus 1, that's 5/3, divided by 5/2. Remember, that's the same as 5/3 times the reciprocal, 2/5. So it looks like we have a slope of the secant line of 2/3. So now we want to know when the derivative would equal 2/3, because that's where the tangent line would have the same slope. So to find the derivative here, we'll have to apply the quotient rule. So we'll start with the denominator squared. Then we have the denominator times the derivative of the numerator, which is 1, minus the numerator times the derivative of the denominator, which is 1 as well. So the derivative equals 1 divided by x plus 1 quantity squared. We want to know when this is going to equal 2/3. This is a proportion, so now we can perform cross products. 2 times the quantity x plus 1 squared must equal 3. Let's go ahead and take that onto the next screen. So again, we'll have 2 times the quantity x plus 1 squared must equal 3 times 1, or 3. Let's go ahead and multiply this out and see if it's factorable. So we'd have 2x squared plus 4x plus 2, and then we'll subtract 3. Okay, so this is not factorable, so now we'll have to apply the quadratic formula. So we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We need to simplify this. 24 is 2 times 2 times 6. So we have negative 4 plus or minus 2 square root 6 all over 4. Simplifying this, negative 1 plus or minus square root 6 divided by 2. Remember that our interval is from negative 1/2 to 2. So negative 1 minus square root 6 divided by 2 is less than 1/2. So the only value of c that we can use is negative 1 plus square root 6 divided by 2. Let's go ahead and convert that to a decimal. It's approximately 0.2247. That'll be helpful when we look at the graph next. So what we found is the slope of this secant line was 2/3, and when c is approximately 0.2247, or somewhere in here, the slope of this tangent line is also equal to 2/3. Let's take a look at an application problem with the mean value theorem now. 2 police officers equipped with radar are 3 miles apart on a freeway. As the truck passes the first officer, it is clocked at 55 miles per hour. 2 minutes later, the second officer clocks the truck at 52 miles per hour. If the speed limit is 55 miles per hour, should the truck receive a ticket? The first impression would be no, because it's only been clocked at 55 and 52 miles per hour. By using the mean value theorem, we can actually gather some more information from this situation. First thing, our rate is in miles per hour and our time is in minutes. So we need to convert 2 minutes into hours. So 2 minutes, since there's 60 minutes in 1 hour, this would be 1/30 of an hour. Okay, so what we're going to do is find the average rate of change in this situation. Remember the equation distance equals rate times time. Well, if we solve this for r, or rate, we would have the rate is equal to the distance divided by the time. So if we can find the average rate for these 2 minutes, it'll help us determine if the truck should receive a ticket. Well, the change in the distance was 3 miles, and the change in time was 2 minutes, but that's equal to 1/30 of an hour. Well, 3 divided by 1/30 is the same as 3 times the reciprocal. So what this tells us is the average rate of speed was 90 miles per hour, even though the truck was only clocked at 55 miles per hour and 52 miles per hour. Somewhere in this 3 miles, that truck must have hit a top speed of 90 miles per hour at least once in order to travel that distance in that amount of time. So this would be the slope of that secant line, and so the mean value theorem verifies that some other time this truck must have reached a speed of 90 miles per hour. I hope you found these examples helpful.